National Electrical Code Article 310.6 requires shielding for conductors carrying over 600 volts, nominal, unless one of four exceptions applies. The first exception applies to conductors forming part of a cable assembly. The second exception applies to conductors installed in a raceway. The third exception applies to conductors located outdoors. The fourth exception applies to conductors installed in a multi-conductor conduit or tubing that has an insulated or isolated barrier between conductors. These exceptions do not apply to cabling from the load side of a close-coupled disconnect switch to the primary of a transformer when the primary voltage of the transformer is larger than 2000 volts. Therefore, shielding is required in this case. To elaborate on the specifics of National Electrical Code Article 310.6, it's crucial to understand the purpose of shielding in high-voltage cable installations. Shielding serves primarily to contain the electrical field surrounding the conductor, reducing the risk of insulation failure, electrical discharge, and potential hazards to personnel. When conductors operate at voltages exceeding 600 volts, the electrical stress on the insulation increases significantly, making shielding a critical safety measure. The absence of shielding in high-voltage applications can lead to several problems. Firstly, it can result in partial discharge, also known as corona discharge, which occurs when the electric field exceeds the dielectric strength of the air or insulating material. Partial discharge can degrade the insulation over time, eventually leading to insulation failure and potentially causing a short circuit or ground fault. Secondly, the uncontained electric field can induce voltages in nearby metallic objects, posing a shock hazard to individuals who come into contact with them. Shielding provides a controlled path for these induced voltages, directing them safely to ground. The National Electrical Code recognizes the importance of shielding in high-voltage installations and mandates its use to mitigate these risks. Article 310.6 outlines the specific requirements for shielding conductors operating at voltages above 600 volts, nominal. It states that all such conductors must be shielded unless one of the enumerated exceptions applies. Let's examine each of these exceptions in more detail to understand their limitations. The first exception pertains to conductors forming part of a cable assembly. A cable assembly typically consists of multiple conductors bundled together within a common jacket or enclosure. If the cable assembly is designed and tested to meet specific performance standards for high-voltage applications, including insulation integrity and shielding effectiveness, then the individual conductors within the assembly may not require separate shielding. However, it's important to note that not all cable assemblies are created equal, and it's crucial to verify that the cable assembly is indeed rated for the intended voltage and application. The second exception applies to conductors installed in a raceway. A raceway is an enclosed channel designed to hold and protect electrical conductors. Common types of raceways include conduit, tubing, and cable trays. When conductors are installed in a raceway, the raceway itself provides a degree of mechanical protection and containment for the conductors. However, the raceway alone does not provide adequate shielding for high-voltage conductors. Therefore, this exception typically applies only when the raceway is made of a metallic material and is properly grounded. The grounded metallic raceway acts as a shield, intercepting and redirecting the electric field surrounding the conductors. It's crucial to ensure that the raceway is effectively grounded to provide a low-impedance path for fault current and to minimize the risk of voltage buildup on the raceway itself. The third exception applies to conductors located outdoors. This exception recognizes that outdoor installations are typically subject to different environmental conditions and safety considerations compared to indoor installations. When conductors are installed outdoors, they are often exposed to open air and are less likely to come into contact with personnel or other equipment. However, this exception does not eliminate the need for shielding altogether. Even in outdoor installations, shielding may still be required if the conductors are located in close proximity to other equipment or structures, or if there is a risk of induced voltages or partial discharge. Furthermore, the National Electrical Code may impose additional requirements for outdoor installations, such as increased clearances and grounding requirements to ensure safety. The fourth exception applies to conductors installed in a multi-conductor conduit or tubing that has an insulated or isolated barrier between conductors. This exception is intended to address situations where multiple conductors are installed within a common raceway, but each conductor is physically separated from the others by an insulating or isolating barrier. The barrier prevents the electric field surrounding the conductors from interacting with each other, reducing the risk of insulation failure and partial discharge. However, this exception is subject to certain limitations. The barrier must be effective in preventing electrical interaction between the conductors, and the raceway itself must be properly grounded to provide a low impedance path for fault currents. Moreover, the National Electrical Code may impose additional requirements for multi-conductor installations, such as directing factors to account for the increased heat generated by multiple conductors in close proximity. In this specific scenario of cabling from the load side of a close-coupled disconnect switch to the primary of a transformer with a primary voltage of over 2000 volts, none of these exceptions typically apply. The conductors are not part of a cable assembly that is specifically designed for high-voltage applications. They are not installed in a grounded metallic raceway. They are not located outdoors in a manner that eliminates the risk of induced voltages or partial discharge. And they are not installed in a multi-conductor conduit or tubing with an effective insulating or isolating barrier between conductors. Therefore, shielding is required in this case to ensure the safety and reliability of the electrical system. The type of shielding used for high-voltage conductors can vary depending on the specific application and voltage level. Common types of shielding include metallic tapes, braids, and extruded semiconducting layers. Metallic tapes and braids are typically made of copper or aluminum and are wrapped around the conductor insulation to provide a conductive path for fault currents and to intercept the electric field. Extruded semiconducting layers are made of a semiconductive material that is bonded to the conductor insulation to provide a uniform electric field distribution and to suppress partial discharge. The selection of the appropriate type of shielding depends on factors such as the voltage level, operating temperature, and environmental conditions. In addition to shielding, proper grounding is essential for high-voltage cable installations. Grounding provides a low impedance path for fault currents, allowing protective devices such as circuit breakers and fuses to quickly interrupt the circuit in the event of a fault. Grounding also helps to minimize the risk of voltage buildup on metallic objects, reducing the potential for electric shock. The National Electrical Code specifies detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods of connecting grounding conductors to equipment and structures, and the location of grounding electrodes. It's crucial to follow these requirements carefully to ensure the safety and reliability of the electrical system. Furthermore, regular inspection and maintenance of high-voltage cable installations are essential to detect and address any potential problems before they escalate into serious hazards. Inspection should include visual examination of the cables, terminations, and grounding connections, as well as electrical testing to verify installation integrity and shielding effectiveness. Maintenance should include cleaning and tightening connections, repairing damaged insulation, and replacing worn or deteriorated components. By implementing a comprehensive inspection and maintenance program, it's possible to identify and correct potential problems early on, preventing costly downtime and ensuring the safety of personnel and equipment. In summary, National Electrical Code Article 310.6 requires shielding for conductors carrying over 600 volts, nominal, unless one of four exceptions applies. These exceptions are limited in scope and do not typically apply to cabling from the load side of a close-coupled disconnect switch to the primary of a transformer with a primary voltage of over 2000 volts. Therefore, shielding is required in this case to ensure the safety and reliability of the electrical system. Shielding provides a control path for fault currents, reduces the risk of insulation failure and partial discharge, and minimizes the potential for electric shock. Proper grounding and regular inspection and maintenance are also essential for high-voltage cable installations. By following these requirements carefully, it's possible to create a safe and reliable electrical system that protects personnel and equipment from the hazards of high voltage. Always consult with a qualified electrical engineer or contractor to ensure that your electrical installations comply with all applicable codes and standards. They can provide valuable expertise and guidance in selecting the appropriate equipment and installation methods for your specific application.